I'm here to talk about decentralized artificial intelligence. So first, why do we need decentralized artificial intelligence? The problems with centralized artificial intelligence, so first of all, knowledge is decentralized, but AI is not. Knowledge, as we know it, is basically scattered around the world. There's no single person that knows everything. And it's through collaboration and sharing of knowledge is where we get where we are right now. And that is what brought us at the top of the food chain, for example. Close collaboration is also a limitation with centralized artificial intelligence. Basically, since all of the models and all of the data is being centralized, there's a limited amount of people that is actually working on artificial intelligence. So there's a lack of data for the startups that do have the capacity to apply artificial intelligence. And there is a lack of skill set for the traditional organizations that do have the data but can't apply the technology. So it's a monopoly game, basically rich get richer in a way. So only these powerhouses that do have both the data and capacity are able to use AI, and they enter this cycle of continuous feedback, which gives them the edge over everyone else. Other limitations with centralized AI is bias. Everything with artificial intelligence is based on bias. So you have data scientists, they pick the models, they select the data, and they train the data. And all of these basically lead to the bias of the data scientists that apply the technology are part of the result of the computation that is done. So there's a lot of bias. And another is transparency and influence ratio. This is a link to an article about the CEO of Google. And basically he says that he thinks that the users of Android mobile devices are totally aware of the data that is being gathered of each user. I don't agree with him. I think most people are very unaware of the amount of data that's being gathered and the amount of knowledge that's being gathered from everyone. And there's no transparency of what they're doing with the data. We've seen a lot of political even movements happening online through manipulation and basically influencing the people without them even knowing it, because they know more than we do about ourselves. So what are the challenges with distributed AI? So the problems that I mentioned earlier are possibly fixed through distributed AI, but we're still not there yet. And the challenges are, first of all, is an economic problem. How do you incentivize people to participate and collaborate? There was no solution a few years ago, but now with distributed ledger technology, we might be able to implement these incentives to basically incentivize people to contribute and to contribute in a decentralized artificial intelligence. Privacy is also a big problem. A lot of companies they would want to share their data to other data scientists, basically, to get more results out of it instead of just relying on their own internal team. But there's no safe way of sharing data, or there was. And another one is influence. Can third parties contribute to the behavior of knowledge in AI models in a way that is quantitatively influential? Basically, these people, they have all of the influence, and you want to have influence of the whole world, like I said, instead of relying on these parties and their biases to contribute. So the solutions, first of all, the economic solution, blockchain is a possible solution to incentivize people. For privacy, there are a few. So homomorphic encryption is one. Again, cryptography is also another one. Secure multi-party computations, and even zero-knowledge proof, but I didn't include it. And influence, how do you basically gather input from more people than just these central party, is through federated learning. Big disclaimer, I'm not a cryptographer, so I'm just gonna give you guys a toy box example of these solutions. So the economic problem, I might as well go fast through this. We all know blockchain technology, distributed ledger with nodes connected to one another. They're in consensus, so they agree on the current state of the network. And then it's an immutable ledger, so add only, and there's no tampering with the data being added to the blockchain. The privacy problem, homomorphic encryption, a mapping of mathematical sets into or onto another set of itself in such a way that the results obtained by applying operations to elements to the first set is mapped onto the results obtained by applying corresponding operations to their respective images in the second set. So what this means is that you want to basically encrypt the data in a way that allows you to do computations with it and then be able to decrypt it. So this is a really hard problem. I think the guys from Ocean can explain it better. But what you want to do is you encrypt the data in a way. So for example, let's say you want to do a computation of just adding a number. So your input is number 8 and number 10. And then you encrypt it, toy box example, you add 2 to each number. So you get 12 and 10. And then you add them, and then you get 22 as a result. But that's not the same answer that you would have gotten without encrypting it in the first place. So once you did a computation, you get a result, and then you're able to decrypt because only you know the input or the random number that you added to the computation. I think that confused everyone. But yeah. There are a few applications or implementations of homomorphic encryption, and you have partial and full homomorphic encryption. The implementations with partial are, for example, unpadded RSA, LGML, and Palier. And for full homomorphic encryption, it's still pretty conceptual. There's no real implementation there yet, to my knowledge. And the challenges with it is that it's computationally heavy. So the amount of computation needed for simple computations can even be up to a year of computation. And that makes it, for now, unfeasible to apply. But it's still in its infancy in the space. Another approach is the generative adversarial neural networks, or GAN. The idea behind it is you have a generator and you have a discriminator. So one example would be you have a generator that basically generates new images and a discriminator that is able to tell whether an image is real or generated. And you apply machine learning models on both ends. So basically you have a continuous feedback loop of better generations and then better discrimination. So they keep on providing each other with feedback and creating better results. So with cryptography, what this means is you have, for example, Bob and Alice. They want to send a message to one another. And you have Eve that wants to eavesdrop on the message. So you want to apply GAN to this problem. So what the generator part is Alice and Bob are gonna generate their own encryption schemes, and Eve wants to basically intercept and decrypt those encryption schemes. So this is done without any input of previous encryption scheme. So they basically start from scratch, generate some encryption, get feedback, update it, and vice versa. So you have this continuous feedback loop of coming up with new encryption schemes. And secure multi-party computation. So the idea behind this is you want people to provide input data in a, let's call it a black box, and they want to get the result out of it. So you only know your own input and you only know the output of this algorithm. So one example would be, let's say Eve, Bob, and Alice want to compute their average salary. So you start with Eve. Eve adds her salary plus some random number and then passes it on to Bob. Bob adds then his salary plus some random number, passes it on to Alice. Alice adds her salary plus a random number. So now you have a sum of all of the salaries plus a sum of all of the magic variable numbers. So that gets passed on to Eve, and then Eve subtracts her magic number, pass it on to Bob. Bob subtracts his magic number, pass it on to Alice. Alice subtracts her magic number, pass it on to Eve. So now Eve has the sum of all of the salaries without knowing the salaries of each individual person. And if you intercept any of these messages being passed, you still have no information about the salary itself. So now Eve knows the sum, and she is just able to divide it by 3 and figure out the average salary. And Bob has to do the same, and Alice has to do the same. So all of these guys basically know the input and the output, but none of the other inputs of the other parties involved. There are a few projects working on this. I'm familiar with Enigma, that is doing secured computation, multi-party computation, and Oasis Labs. So there aren't that many, and it's still up and coming. And the influence problem. Basically, you want to get influence of everyone around the world instead of these siloed data scientists. And one solution is federated learning. Federated learning is first proposed by Google, and the benefits of applying federated learning is the data or the input is kept secret, and another is the distribution of the computation is also a beneficial factor instead of doing it all in-house. So how does it work? So you have all of these parties basically providing input, or traditionally how it would work is you have all of these parties, they have their own input, and they do a computation on their input, on their own device. So they don't send it to Google, but they compute on their own device. The output of that, that's what they send to Google. So now you have distributed computation. You don't need powerful machines centralized in one data center, and the input is unknown. It's just the output is given. And also the gathering of the data it doesn't gather to one centralized point. So you have distributed computation and distributed basically input of the data. And then the output gets sent to Google, and then they can use it to improve their model. So you want to distribute this. So basically what you do is the same, but instead of sharing the output with Google or some party, you share it among the network. So this way you can create some collective intelligence within the network instead of having some centralized party that is the only person that knows the output of these models. So that was the solutions to all of the problems that we had. It wasn't possible until a few years ago, as we know, with all of these new technologies. The idea existed, but it wasn't possible to apply. But now it's becoming increasingly possible, and hope to see some cool solutions. So last, I want to end with a project that we did. So we participated in the hackathon this year in April, where we came up with Grex. The idea behind Grex is to combine swarm robotics with blockchain technology. In traditional swarm, you have each agent only knows about local knowledge, so what it can observe and what it can communicate with adjacent agents, but the global knowledge of the network, so what do they do, what is the goal of the swarm, these are all managed by a central authority. And by combining swarm robotics with distributed ledger technology, you basically gather global knowledge within the network instead of relying on that trusted third party. So we developed a really simple proof of concept of the idea, where we had multiple machines. So we had simulated drones, which are the yellow dots. We had beacons, videos, energy stations, and repair stations. And it is when you combine all of these elements together, you can build basically a self-sustaining ecosystem of autonomous machines that are able to execute different types of mission. And we focus on search and rescue. So first you have the exploration phase. So the drones basically move around, try to find someone in need. And then one of the drones basically detects that someone is in need. So the orange dot is a drone that detects someone that is in need, and what it does is it propagates a transaction to the network, and that gets picked up by other machines in the system. So the scouting drones aren't able to help the person itself, they only detect where it is, but that triggers a transaction which is propagated to the network and gets picked up by the one that is responsible for executing the rescue mission. So we build it. Last step, convergence. So once it detected, the other agents basically move to help the person that is in need. So we developed this proof of concept, and we've put it open source online. And the idea is that it's just a basic framework for you if you want to do some experiments. So you might be able to change the blockchain stack that we used, or you might optimize the search algorithm, because now we just used a random walk. We had 2 days to implement it. But you can just use this, build your own experiments, and it also has a nice interface which gives you basically overview of your experiment. So check it out at github/Kryha/Grex, and hope you guys build some experiments with it. Thank you.